So let's start our discussion of the detailed steps of using the DesignPH tool by beginning at the beginning, where we start with any DesignPH workflow, that is the modeling of the geometry of your building. So whether we're talking about a big building, a small building, the first step, of course, is to just rough out or model all of the various bits and pieces of your building. Now, there's a couple of interesting quirks to the way that we have to model for DesignPH. But I think now that you have a lot of experience with the PHPP, some of it will be quite obvious. Remember, the DesignPH is an interface. It's a method of getting PHPP the data that it wants. So when it comes to the surfaces of our building, there's really only a very few things that the PHPP wants to know. It wants to know surface areas, it wants to know U values, and it wants to know exposure types. And so when it comes to modeling any type of building in the DesignPH world, we're going to model everything as simple surfaces with no thickness. It's a very particular type of model that we have to create. And it's created always with an eye towards the PHPP. The whole point here is to make a model whose data flows seamlessly into the PHPP. And the PHPP just wants to know surface areas, so all we have to do is just make a simple surface model. And this, of course, marries very well with the way that SketchUp approaches modeling, where everything is based on surfaces and edges. SketchUp doesn't really, realistically, have a language of things like solids. It really just has surfaces and edges. That's the way that the SketchUp tool is built. So we're going to build all of our model as a sort of a balloon version of the building, or a jello mold version of the building. We're just going to build that outer skin of the building. In fact, the best way to go about it is to really not even consider things like shading or extensions, footings, eaves, overhangs for the first instance. What you really want to start with is modeling the thermal zone, all of the heat loss surfaces of the building. So we want to start with a kind of a weird version of the building. We're going to strip away all of those extra bits and pieces, and we're going to model just the heat loss surfaces of the building, and we're going to control those in a very particular fashion so that their data flows into the PHPP. Now, of course, we will add back in all of those other bits and pieces, things like overhangs and eaves and porches and ground surfaces, etc., etc. But those will all get added as extra elements. Those are not heat loss surfaces. Those surfaces will be important when it comes to doing things like calculating shading, but we're going to put those in separate groups. We'll put them on a whole separate layer. We'll sort of keep their geometry a little bit segregated from our heat loss surfaces, from our basic thermal zone. So we're in many cases going to kind of split up the geometry of the building in a way that doesn't realistically map onto the real world. Your roof might actually just be one big surface, but for our purposes, we're going to split it into the heat loss component. And then, as you see in the image here, there's a little extra bit that's going to be related to shading, but that eave, that overhang there, would not be part of the heat loss surface of the building. And so we're going to kind of split that off and put it in its own little bucket. Now, one other thing to note that at this point in our modeling, so in the beginning, we're going to model all of our windows just as flat planes, coplanar with the wall or roof surface that they're hosted in. We're not going to give them any frames. We're not going to give them any glass. We're not going to give them any thickness. For now, we'll look at how we manage those in later steps. But for now, we're just going to model all of our windows as simple flat surfaces, just flat planes. And remember, PHPP can only accept rectangular windows. Remember, the PHPP window section asks us to input a length or a height and a width. It has no ability to take in arch top or round windows, triangular windows. So all of your windows have to be rectangles. So for the PHPP and for the DesignPH, all the windows have to be rectangles. Now, we'll talk about this in a few minutes, but one of the things that we have to do with our model here is, of course, we're going to apply some material information, some U-value information to all of our surfaces. We're also going to apply some exposure information to all of our various surfaces here. And what that means for us in practice is that oftentimes we end up building our 3D model in, again, a way that doesn't really map onto the physical reality of the building. For the case here, that's probably one wall surface. That's one foundation wall surface. But as far as the PHPP is concerned, it doesn't really care whether it's one surface or two surfaces. What it wants to know is how much surface area is exposed to above grade air and how much surface area is exposed to below grade soil. And so it's very, very common for us to go through and split or segment what is in the real world one surface into various bits and pieces, and we would split it so that we can apply different parameters to different pieces. So if we have a below grade portion, above grade portion, if we have an R21 portion and an R31 portion, we would have to split those into separate surfaces so that we can control those parameters. So this is not uncommon at all. And the long and short of it is that it's almost impossible to use the native or raw architecture 3D model. You're really building out a purpose-built building information or building energy model, which is going to be built and adapted and tweaked to exactly what the PHPP wants and needs. So for the most part, you're going to end up remaking your building model with an eye towards the PHPP. Now you might be asking or looking at this image and thinking to yourself, well, that doesn't look right. Of course, a building like this would have spread footings underneath it if it's in a climate which has frost risk or anything like that. And of course, you'd be right. The footing of the building, the geometry of the building doesn't look like the SketchUp mass there. In this case, let's suggest that it does have a spread footing running around the building there. So how do we manage that in something like the DesignPH? How are we going to model that appropriately? Should we model the geometry of that footing? Should we build in or draw surfaces for all of those edges of the footing there? And the short answer is no. That would be an incorrect way to model that. You want to model the wall surfaces and the floor surfaces, all the basic geometry, and then we're going to use our psi values to correct for those junctions and corners and edges. Remember, the psi values, the thermal bridging coefficients, those are going to be defined as a correction factor. Those factors are used in our model to correct for the difference between the basic heat loss of the surfaces and the actual heat loss with the actual geometry at the corner. So it's very common for us to model a relatively simplified planar energy model, and then the nuance of all of the particular geometry of these types of intersections, something like the footing here, this all gets taken into account in those psi values. And the psi values are going to be a really, really straightforward and simple way to manage all of that information. So when it comes to the modeling, you're going to model a very simple building, eliminate all of those eaves, overhangs, footings, parapets, etc. Strip it back to the basic thermal zone, the thermal mass of the building, and the simple surfaces of the building. And then we add in the nuance of all of these edges and corners and disruptions using these psi values. So when we come back in the next series of videos, we will take a look at what else we have to do to these surfaces. So once we've built the surfaces, how do we start to apply additional information to those surfaces? How do we tell the PHPP, this is the below grade, this is an above grade, this is an R21, this is an R31, etc.?